Good evening, everyone. Gonna give it a minute or so to let people come and join. You're always such a cutie. Evening. Yeah, to you too. Welcome back to Categories. Gotta love how Steffi's here, but I refresh users in chat and well, she's not showing. Oh, Twitch is all kinds of broken, yes. 7 people already watching. Well, so, introduction to today's stream then. So this is SPIFlashProgrammer V2 for those who don't recall. And as per the note, needs more flash. So the first thing I'm going to be doing with tonight's stream is taking this board and finding flash chips that we can throw on that are preferably DFN. We'll probably put them on the back side of the board or something like that, so that we have onboard memory that we can use for bit streams that, like, let's say you're trying to use this in a mass production environment and you've got like 2 bit streams that you need to put onto 2 different components. Then you'll have a user button A, a user button B, which we're going to put over here, and then you press one of them and it programs the target device with whatever is in that flash. That's the idea. So it'll be 2 flash devices for 2 bit streams, or 2 firmware images or what have you, and then you click the button and it puts whatever's in that flash on the target, as well as its normal usage where you plug a USB cable in and then you use it with a host machine. That's the idea. So, and that's this board. We'll also do some stuff in KiCAD nightly, which for those who don't yet know, I am the proud maintainer of KiCAD Nightly. Oh god, what have I done? And it's shaping up nice. So we're going to use it to design the board I need for the keyboard. Yeah, welcome to being an AUR maintainer. Exactly. Yeah. Yeah, you don't even know the half of it, Steffi. It's a whole thing. Oof. Yeah. Yeah. Yeah, so you do apparently. Anyway. And the idea with the second board is it will take us from USB Type B device to Type C, so that we can plug the keyboard into things like my phone, because that would be quite handy for testing. And we're going to use the Nightly for that, which... that's going to be fun. So, I need to grab a browser. Make it so you can actually see what I'm doing, but we'll also switch to schematic view in the same process. So, let us go semiconductors, all. Come on, Farnell. And... What's 2 packages between friends though, right? I think it might well be memory. Indeed. Which, I'm still kind of shocked, by the way, that Aki had been using this Gold Canary for like, I kind of think like a year or more. I had no idea that you would maintain her. Just quite happily using it. Okay, this is annoying. It keeps putting the filter down the side, and I actually really want it along the top here. This is easier for you to see, and it's easier for me to use. Farnell, damn it! So, my first criteria, in this case, is actually going to be package. I don't want to go for something too small. And I forgot to turn my phone dinging off. Apologies for that. And we actually want to go for DFN or QFN, basically. Oh. There's a story there. Now I'm intrigued. So one of the things I'm going to ignore here is this WSON package. This is like the WLCSP. It's a chip scale package. It is bloody tiny, and I am not prepared to try and solder one of those. So we'll ignore that. WDFN is a wide DFN, which we might not really want, but I'm going to pick it anyway. VDFN should be a slightly bigger DFN package, which ooh. That is cursed. Ooh. Yep. What's the pin pitch on that, Sylvia? Also, that sounds like a WinBond part, which I kind of want to avoid WinBond for on the board, because those parts are cursed. Welcome, Obliterous. And yes, welcome, Sylvia. Although I guess with it being 8 by 6 millimeters, it's going to be 0.5 millimeter pin pitch, so that's not too bad. Bit wide, but not too bad. Let us see. We've also got UDFN. We'll want that in the list. We'll ignore TSOP because that's not a fun part to deal with. Because it's really big relative to everything else on our board. SOIC, again, I'm going to ignore it because it's kind of huge. And I don't want the JNEED version of that. I definitely don't want to do a PLCC, because I don't have the patience for that. Honestly. I'm ignoring all the BGA stuff. I have dealt with TSUP, but with a power pad, and it's no fun. Mind you, I've also dealt with, and this is super cursed, I have dealt with X2 SON Ah, never again. Those things are so small. And the process that Osh Park provides cannot do that well. It's worse than reflow only. You can't get solder mask in under them, they're so small. So it's reflow and pray. It's way worse than just reflow only. It's reflow and pray. Sucks to be a power regulator, which was what I used it in. Oh wow, okay, that's... yeah. Well, we'll see what we get with this. Yeah, that actually looks pretty good. We'll also do no delivery surcharges so that I don't get stuff from the States or stuff from Luxembourg, because that's really expensive. It's like 15 quid a part import duties extra for coming from either of those two countries. Kind of obscene. We'll do a sort by price. Aww, you've been waiting a while for those too. Ah, right, I also need to remove re-wheeling and other options. And I don't know why it keeps doing this. You hit the button to say use the top and it goes back to the left every damn time. Well, let's do cut tape. Oh, maybe. Interesting. Also, it all keeps loving to ask me about cookie policy. It's like, I've already hit the OK on that, thank you. So stupid. I'm gonna ignore this one. In fact, I don't really recognize Adesto Technologies. They have a really weird command set to do the extra large size stuff, and it's just... it breaks a lot of stuff to do with how the original 25 series was done. Ah, I even need to update Streamlabs. Because that's not what we're making this stream. Any good? Because I was going to go and just filter them out for someone like Microchip or Cypress. Seeing all the other usual suspects are grayed out at this point. Although they seem to be the one that does most of these, so... Interesting. Also, we need to figure out what size we want. I think I want 32 megabit and up, because that's actually not very much space for like a bit stream or other reasonable data that you might want to put on a board. Where is my timers? There they are. Interesting. See, the way that SPIFlashProgrammer is written is it actually expects locked by default and unlocks as the first thing it does. Interesting. Okay, well, I think we might go with the Nadesto part then. I've never used them before, but welcome, Naz. Just fixing Streamlabs because it thinks we're doing the wrong board. And a USB micro B to Type C adapter. Aww. Welcome, welcome, Amy. So I think, because 13 megabits is... 32 rather, sorry. Fair comments, well not. Sylvia. I think Obliterous is telling me that Adesto is a really good choice. Cool, we'll go with that. But yeah, so this is only 4 megabytes is the smaller size here, so I think we want to try and go as big as we can. Which actually will be easier than getting a larger one. Oh, sorry, smaller one. Interesting. How big is this? Let's check some data sheet. Interesting. And this can go way faster than we can program it, so... Fair enough. My usual go-to would be in somewhere like ST or Microchip. But they apparently don't make in UDFN. Whatever that's about. Okay, I've just never come across their parts before, so... But that's good to hear. Like, reputable is good. Ah, nice. That looks pretty standard. What I'm looking for, and it's probably at the bottom, is the... yeah, this. So this is the UDFN... well, yeah, this is the UDFN part. Which... I'm looking for E. Is friggin' huge. Welcome, Jiggly Girls. Okay. I like this. How big is this thing on the board? D and E. 5 by 6 millimeters. That's not bad. Let us quickly sketch on the board how big that is. I need to make sure I'm in millimeters on the right grid, but, you know. Two, three, four, five by 1, 2, 3, 4, 5, 6. That looks to be what it'll end up looking like. Ish. I'm not sure that that's actually where I want to place those, but like, you get the idea. That's not too big. It is a fun username, isn't it? What I probably actually would do is not grab that part. Is probably put like one here, and just have them down the side of the board on the back side. I think that'll be fine. Hopefully that'll be okay. The other place I could do it is actually over here. Either which way, we've got some space. Which is the important part, really. So, and it's nice and cheap, which is good because we're gonna have 2 of them. So I am going to bump the browser over onto a different screen real quick so that we can then... Oh, awesome! That's really great to hear, because I know you put a lot of time into that. So, also we've got to fix some stuff in the schematic here. I am going to pull open the footprint library and let's see what we can find in the way of footprints that already exist that match the part. Which will be probably this lot. UDFN. Ha. It doesn't exist in the library! Joke's on me. That's fine. It's fine. I don't even want to know, honestly. Because it sounds like hell. Oh, that's awesome. For those who aren't aware, by the way, Obliterous has been doing a whole pile of stuff to do with space. Hence to talk about special solder alloys that don't suffer from tin whiskers, among other fun phenomenon. And hence why the weight is so important. CubeSat stuff. Let's see what the wizard can do. We are wanting to do QFN. Well, actually, technically DFN. Yeah. I can imagine. Interesting. We don't actually have a DFN type in here, so I'm just going to make one rather than wizard it. I don't recall off the top of my head. Obliterous, would you like to answer that one, please? Lead. It's Indian based. I'm only delegating Twitch questions, Viable Clan member. Welcome, by the way. Because I actually don't recall what Obliterous told me the alloy was that he got to use. Welcome, Eston. So this one is Ah, good question for you, Eston. Welcome, by the way, for the second time. But which way around is it preferred that you put the dimensions? Is it width followed by height, or height followed by width? Cause yeah, this is not a square part. Width followed by height. Excellent. So 6 by 5mm. Oi, what's that supposed to mean? Huh? I almost want to say I should have been using underscores there. I'm gonna quickly go and look at a existing part just to... I am going to use KiCAD nightly on this stream. I'm just not going to use it for this board. I actually have both installed. Not that one. I meant to do new footprint. So it's 1EP underscore that pin pitch, which is 2.7mm. Sorry, 1.27. Yeah. That would drive me bonkers on the keyboard, because that thing is an Imperial unit. It kind of has to be, unfortunately, because of the way that the manufacturer made the keys. The pad for this is 3.4 by 4mm. Yeah, you've clearly never met my head and measurements, and how I will get the wrong scale even. It's great. Yeah, that's fair, Aston. I will get the decimal point in the wrong spot pretty much every time I try and talk about how big something is. It's just a thing. In this case, Aston, it's an annoying enough part where I think I'd have spent more time trying to make it right than just doing this. Because I should actually start with that tool. So let's do an SMD, rounded rectangle pad. The pads are... Oh, how big are you? Length is 0.6, and height is 0.4. That's the actual physical size of the pin, and I'm going to have it stick out by about double, I think. No, that actually is a bit big. Let's just do one. And we are going to switch grids because this thing is on an Imperial grid. It's great. I think I want to do this. That would be really interesting to play with. I'm just gonna double check. I didn't actually bother checking this, but this has actually come out fine for the round rect, so that's nice. We also need to set up the exposed pad, which E2. 3.4 and 4? Yeah, 4. That's a bit big. Don't worry, I've still got to fix where these are, so we'll fix that in a moment. The other thing I will need to do is set up the silkscreen and courtyards. Yes. Agreed. So we want F-Silk. Thinking face, or thinking sounds rather. Indeed. So this value, because E is 6 millimeters, this is -3. But we've made the pin 0.4 longer. Yeah, when my face gets the busy wheel overlay. Indeed. That was the wrong one to edit. Balls. -3, that one. There we go. So I'm one grid square off. Wonderful. There. That's what we want. Fair. Just gonna see 1, 2. Doing a thing on the silk screen again real quick because this is gonna drive me batty if I don't have it. There we go. I'm not going to draw like lines through all the pins and stuff like that. I'm just going to draw some basic, like, this is where the footprint is-ish. 1, 2, 3, 4, 5. There we go. Oh, right, yeah, those are still in the wrong spot because they need to go over to the left by, 1. I think FreeCAD can do that. Granted, FreeCAD is also made of living hell, but that's going to be another topic for another stream. Wow. Wow, that is messed up. One more pin. Then we can do the courtyard, which should ideally probably be about here. Oh, you don't even want to start to know how bad it's been for me on the keyboard. Oh yes, it's been interesting. Try and guess how many constraints are required to express the complete board with regards to all of the keys. I know I've just made that not square. We'll fix that in a moment. So, just to express the squares for the key plate holes, there are 106 of them, requires 448 individual constraints. The grand total ran me up at 1,484 constraints. Oh yes. It was fun. So, I have some ideas. Oh yeah, very, very many. I have some ideas for FreeCAD that would make it run way faster. So that's going to be a thing. I did not need another project, but I have another project. It's a whole thing, Steffi, it's a whole thing. A tile? What? The constraint solver is not just single-threaded, it's in Python and single-threaded. Yeah, that's why it sucks. Why? Oh, that's off-grid, that's why. Like, why can't I get this to all line up? That's why. Not this, unfortunately, Amy. What it is, okay, Steffi, I know you're going about soul space, that's fair enough. I've already done a whole ton of stuff in FreeCAD and I can't move it from there easily. And I also don't want to have to learn yet another new tool. What I actually figured out is it could be solved with two really simple things. The first is a pair of booleans that say, is this constraint already fully solved? Yay or nay, in X and Y. The other is actually representing the constraints properly in a dependency tree. Those two things together would stop it recalculating every fucking constraint in the entire thing every time you just do one thing. It doesn't have that. It resolves every constraint in the entire sketch every time you change one constraint or add a new one. Oh, and it does that 3 times. Just for added insult. Yeah. It's not fun. So, you know, there are some really easy performance wins to be had in FreeCAD without just being, fuck it, move to another tool. Let's fix the tool. It's actually not that hard to fix. It just needs a little bit of creative thinking. The other thing I need to do, actually, is going to be do a fab layer thing. Let us... Doop. Doop. And doop. There's the fab layer. And last but definitely not least, we want to do a 3D something. That looks pretty good. It's fixable. And at least it's written in C++ and Python. That's why I'm saying don't just throw it away, don't diss it too much. It actually can be fixed. We should fix it rather than doing the other thing. Because I figured it out, don't worry. Just takes a bit of time to write the code. Does this have a 3D part, or is there a 3D part already in the library? All the disks. So... no, it's the modules, that's right. Package 3D. My question for you, Steffi, is does it run natively on Linux, is it open source, and what file formats can it read and write? If it's designed for 3D printing, it is not suitable for what I'm doing. For what it's worth. Because I don't want step files. Okay. Oh, okay. I might well give it a look, but, yeah, I already have a ton of stuff that's in FreeCAD, and that's going to be a whole stream as well. It can't import anything. That would be problematic. That would be very problematic. See, one of the things I'm using FreeCAD for is taking the board itself and importing as a step file into FreeCAD so I have a fair idea in 3D space of what I can't hit. Because there's physically a board there and there are physically keys and, you know, stuff. Anyway, let me see. So, we have got... I'm just trying to work out which size of this do I want to use. I think this one here is probably the closest to our part. And rather than going and getting another part down, let's just use this. It would be really handy if I could copy the name. Oof. That is... Ah, good to know. That is very limited though, to be honest. Like, oof. Oh. Yeah, go me. I just managed to open stuff in a completely wrong screen. Yay! Good enough. Like, the pad's not there in the back, on the bottom side and all of that stuff, but that's good enough. I'm happy with that. I can imagine if they weren't really inclined to actually improve the product in any kind of really meaningful way, she probably didn't have much time for them on a personality level. Okay. So, the next thing I'm going to do is, because the text size on this is just nuts. Let's just quickly fix that. Ah, it reads much better. I am using mate with a... Oh... Yeah, I can see why she ran the other way very, very fast. So to answer Naz properly, I am using the Mate desktop environment with Cavantum as a theming engine, and on top of Cavantum, I'm using the Materia theme. Specifically Materia Dark with the Papyrus icon pack. Right, the thing I was going to do here is I need to add another sheet or do something on this sheet. I'm going to add another sheet. We're going to add another sheet that has which has the 2 flash chips on it. That one. So this is going to be that. There we go. Sorry, Steffi, we apparently can't have nice things. Though I guess we could always fork it. I just thought of an amusing rename you could do for Solve Space. Trans Space. Welcome back, Obliterus. But yeah, that's fair, Eston. Right, I want to... Memory flash, that'll do nicely. This is an AT25 SF. They don't have the proper part. We're gonna have to make a thing for this as well, aren't we? Because this is not a great symbol. Like, the right protect on hold could have gone over here and the whole thing shrunk. Why are there different variants just for different physical parts? Are the pins moving around? Well, the pins aren't moving around. Ah, this is awful. Okay, we're doing our own. Bollocks. Ganbatte ne! Because, yikes. KiCAD's library is somewhat cursed, yes. Right, I haven't actually yet built a proper library for... KiCAD's not that cursed. Especially not the nightlies. Those are nice. Oh. It's fixable. You'll see. Trust me, you'll see. Give me about, like, half an hour to do this. Oh no, the aura is even going away. You'll like the nightly, I think. You'll be like, wait, what? Cool. Yeah. Yes, you do, Obliterous. It's cute. Right, symbol name. We want, this is... This is SPI flash with exposed pad. Looks good. I need the pinout. There we go, there's the pinout. Orientation, yep, right is correct. This is not CS. Pin 1. Then we have... not SIPO, copy. Pin 5, because I'm not going to use the naming they've used SI, which confusing because it's actually SPI. Then we want a CK pin 6. Winding Steffi up just puts a smile on my face. I'm sorry, Steffi. So this is the output of this device. I deserve that. To be fair, I do deserve that. So this is the hold pin. Hold! Because apparently I can't spell. Lovely. I think this is technically an input, but the other symbol was BiDi. Yeah, see this I'm doing this as a non-QSPI part, because there can always be a QSPI version of it later, if that's actually what you want. That looks good. We just need to add power and grounds and we should be good to go. Curious, Steffi. Yeah, that's kind of expensive. Oh, okay. They haven't marked it as inverted on this, so that's a good call. This was pin 9 in our package, the pad that's under the chip. Which, that should about do it. Let us put a part body in. Yeah, that works. It's a better part than they had, I guess, so that works for me. So we want 2 of those. Sounds good to me. Okay. We also want a couple of capacitors to bypass each of these, because, yeah, these will be power-hungry buggers. Ooh, nice. I don't know why KiCAD does this, but this was nicely in its place in the... And it looks good when it's in the right spot, but this is awful. Currywurst. I like it. Ooh, what kind of stats are you having? Ah, I also forgot to turn off the pin numbering. Ah, it's annoying. Let me quickly fix that. Show pin number. There we go. The perils of America? What? I mean, you're not wrong, but like, what? So we're going to use some hierarchicals. We are going to put a hierarchical SCK in, which is an input to this schematic, an input copy in. Oop. Yes, that was definitely what I wanted. Hierarchical SIPO, which is an output. Ah, yes, fair. Being picky is fine. Tilde hold, and quickly duplicate those over, and then finally we've got chip select 1 and chip select 2. That should probably about do us, right? Now I'm intrigued too. Huh. Yeah. Huh. Good point does XOR. I might Yeah, okay, I need to check a couple of things about this part, one of which is actually the voltages that it runs at. Oh good. Yeah, this is a 3.3 volt part, because I forgot to check that. Huh. Very nice. Shame I can't have things like that anymore. I mean, Steffi, I get exactly no choice. Because I'm lactose intolerant. Yay! That, by the way, doesn't mean I can't have, like, milk and cheddar and stuff like that. It just means I have to get it lactose-free. Which... Hey, do you want some cheddar or do you want some cheddar? Which is not my favorite cheese. It's quite depressing. See, that's another one I can't have. For some reason, goat cheese and I do not agree. It's messy. Yeah, I think I'd have to describe the cheddar you can get as lactose-free cheddar as just mousetrap. That Eston actually sounds like you might be mildly lactose intolerant. Just saying. It really just wants to tell me about how I can talk to the chip, not so much like pull-ups and stuff that it has inside the chip. Grr. I mean, Aston, I'm, yeah, not nearly as old and yeah, completely lactose intolerant, basically. Yeah, limiting to lactose free, it's... Well, next time you're in the shop, go and have a look at lactose-free cheese, Steffi, and you'll see exactly what I mean. It's not great. Absolute maxes. Power up timings. How power hungry is this thing? $25 milliamp. Cool. So there's 50 of our 100 milliamp quota. There are basically two brands, Steffi. Cathedral City, which I despise, and Arla, which actually makes some really good stuff, but there are literally two different strengths of Arla cheddar, and there's they now do a cream cheese, but I don't particularly like cream cheeses. They do a great milk. Really nice and creamy, full cream. And a decent butter. So I guess that does cover the bulk of things, but I really wish there was more than just cheddar. Because it's so boring. My favourite when I wasn't lactose intolerant was Double Gloucester, and my second was Red Leicester. Which you just cannot get lactose free. Okay, so it looks like does Exor's comment about oh, that's fair. See, I like my oat milk in my tea, but I need full cream in my coffee. Go figure. Nah, Red Leicester's a bit more complicated than that, Steffi. The really good stuff is way more interesting than just red cheddar. Yeah, so does Exor's comment about needing a couple of pull-up resistors is correct, it would seem. That's fair, bad at categories, that's fair. Yeah. Right. Back to the schematic then, let us make some room. Oof. I mean, so I really like things like Earl Grey, and I will brew Earl Grey tea for a solid couple of minutes minimum before I'm going to call it strong enough. It's just so I can get the nice bergamot notes out. We want this to be a 10K. I said minimum. Let's make these, right key is V, not the other two. Make these 0.1 mic. I'm somehow not surprised, Steffi. That's fair. I mean, Obliterous, that is a giant mug, so I mean, you're talking ounces and or fluid ounces, and I'm not good at those. What is 30 fluid ounces in Sana units? Let's just check. Yeah, normal units. Okay. Let's just do it in liters. It's most of a liter. It's most of a liter. It's 0.9 of a liter. Well, that's quite the mug. Oh, jeez. Oh well. So I'm gonna set up the resistors as 0603 and the capacitors. I do get that reference, oh god. Bad Steffi, no! What, is that company still actually alive, or has it finally died its death? Bad enough. Right, let us grab the name of this part and throw that in as the value. Awesome. And then let us annotate. And I really wish I had the go-to board thing here. Ah! Not so much something rude as much as the company that I wish just didn't exist. Mistreatment of employees and that kind of thing. It's not great. Mm-hmm. I really wish that Sports Direct would stop being a thing. They're like super fired at this point. Ah. That's not where those are actually going to end up, but let us not forget to actually hook this little lot up, because I've forgotten to do the processor part. Let us import the hierarchicals. Should be all of them. Yep, that's all of them. Of course, it makes the text all really huge, which is kind of annoying. go. Let's go into here real quick and let's see what we can hook up where. So, I don't know if I've kept it open. Oh, I have. Okay. Huh. Let's pull that to the end. Let us check the pinout for its SPI buses, because I'm thinking we probably want this on a separate SPI bus so that we don't have, like, the chip we're trying to program, we can either talk to it or we can talk to our data source. Like, that would probably be a bad bottleneck to build into the board. So I'm going to use a separate SPI bus for this. You know, plenty of hardware in here for all of our hardware needs, so there should be something on one of the other ports. This does not have the chip pinout. That's kind of obnoxious. Fair. Ah, I did save the URL. That's good. Oh, right. This, they removed the datasheets off of all TI parts. I don't know why, but they did. I approve of that use, Eston. That's an awesome way to use a cup warmer. Fair enough. Why keep PCBs warm? It helps with the reflow profile. Reduces cracking of joints and... I mean, anything that means that the board is warmer than room temperature really helps. But preferably you actually preheat circuit boards to like 100C. But yeah, 50-60C is good as a way to just buffer yourself a bit. It makes quite a bit of difference, yeah. Fun. Well, that's because it's a really interesting target to go and run it on. Okie dokie, Eston. Thank you for joining. Take care. Hopefully we're still going when you get back, because I plan to do KiCAD nightly soon. Whatever that ends up translating into. It really depends on this processor, I think. I'm trying to find out where I can attach the extras. Ah, there it is. Okay. Haha, we found it. I approve of the I'll be back reference. That's a good reference. Minus the really hard K. Right. Ah, we also forgot to mark some of the stuff as really definitely disconnected. So, it would be ideal to have it connect over on these pins, which I'm apparently missing the silk screen to tell me the orientation of this. Oh. Well, that's pin 1 there. Ah, I've done it as a dot. We need to fix this part. So got pin 1, pin 15. What have we got down there? We've got port E and part of port C. Cool. Let's see if we can do port C as our SPI pins. Hang on. 13, 14, 15, 16. There's a UART there. Where's the... Ah, haha. So, pin 2122, port A. Oh look, we're already using those. Haha. Ah, okay. Pin 1 is a SPI receive pin. We've then got power and ground stuff, then pin 4 is a transmit for SPI. What else have we got here? So I really need a clock pin. I wonder if that's pin 64. It is not, although there is another SPI bus there. It's pin 61 for the SPI clock for a couple of different SPI modules. That would put us over here. I was really hoping to avoid that because of our JTAG connection. Routing up through here is gonna suck. What other options do we have? No, that's not what I thought I had in my copy buffer. Let's try that. As this way we can just scroll down and we should see highlighted sections of text where the other SPI2 bus comes out to. Ah! There it is. Pins 58... 1 and 4. So that would put us... Signal coming out there. We can do that. And then the rest of them coming out here. It's a very odd split, that. One signal coming from there, the one's coming from there. Why didn't they put them all in a bank? Mad. Oh, no, sorry. The other ones are over here. That makes a lot more sense. That's going to be a bit of a squeeze, though, to get them down here if we keep the memory down here. Ah, there's another bank on pins 19 through 22. Ah, no, that is the one we're using, that's right. 28, 31, and 29. That would put us here. Ah, with vias we could do that. With vias we could do that. Okay. So we're going to do pins 28, 29, and 30 as being our SPI pins, which puts us on port F. This port. Now, that means we're going to need another clock and pair of SPO soppy. F0 for receive. Hello KiCAD. Calling all KiCAD. Oh, that's right, because it's place a hierarchical label. That should be SPO. Then we have F1 is soppy, copy rather. I've got to make the text smaller. Go me. Then we've got our clock. Actually need to differentiate these because we've already got SPO soppy pins. Then pin F3 is available. Because we don't have to use that as a frame signal pin, we can just use it as a chip select. And I think PF4 as well. But that is quite far away. Interesting. Let us see. Do we have something a little bit closer? So much data sheet. Not really. PD7 is probably our best bet for the other chip select, because it's a nice low speed pin thing. Because otherwise it's PF4 all the way down here. Yeah, let's go PD7. I'm ignoring port C on purpose. Am I? Yeah, I'm ignoring it on purpose because we've got we've got JTAG on the other part of port C. But port D isn't doing anything for us, so we'll make it do something. Which, yeah, this pin here. I am actually going to move that to... Let's go about there. Move everything over. Just a touch. Because we're going to put the pins for this down this side of the processor block. Haha, 10, that would be great. That would be huge. Oh, I still need to tie the write, protect, and hold lines. Well, ooh, do I? We'll come back to those. I have a funny feeling we can probably actually just hold them in set modes and just ignore them. Welcome from Tapez. I don't know, actually. That might bear some investigating. So, let us switch back to the PCB. Oh, this is gonna be fun. Let's just chip select 1. Uh-huh. Which is going to this pin over here. Okay. Let's get rid of some construction lines. Oh, I didn't want to edit that, I just want to get rid of it. There we go. Then let's move the other one. No, I'm not actually going to place them that close, it's just some initial shenanigans. That's probably okay. Ooh, that's not what I wanted, KiCAD. I hit M, not edit. Because that should leave enough room for our 2 decoupling caps. Right about there. So if we now turn the courtyards off, and we turn air wires off, I can probably solder that. That's probably okay. Let us actually flip into the 3D view real quick. And look on the bottom. Yeah, I could solder that. That's fine. Oh, we forgot to move the silkscreen into the right place when we did the parts. Oopsie. That's cute. Okay. Actually, I'm going to leave the courtyards off because we don't really need them at this point. I'm just turning off some extra stuff that's available in the footprints that we really don't want. Did that not... Oh, it did take. Ah, it's this part that's got the really awful silkscreen. Got it. Ah, that's more of this footprint which we need to fix. Okay, let us quickly go fix that footprint, and we'll update it because it'll reset everything I've just done to those footprints. This is what I'd got wrong. Whoops. That's much better. So So if we now do all footprints with that identifier. Oh. Really? Ah, that's why. As it stands, we're still going to need to move this down like there anyway. Otherwise, it's going to be off the edge of the board, which is very unhelpful. Ah, that's too close. How's it going to look if we put the silk screen over here? Just barely enough space. That looks okay. Let's just quickly fix the silk screen then for the capacitors and the resistors in all of its derpiness. I'm not... okay. Yeah, I thought so. The original silk screen is actually a little bit close. We've got to fix the part. Haha. Oh, I've also just realized we haven't actually made the footprint entirely correct on account that of this is on account that I'm going to need some wires in here. That's going to be fun. We might as well put some wires in. Because this is also going to be how I solder the part. I'm gonna quickly do a little measurement. I want to see if well, I didn't manage to get the center of the part. That's annoying. That's 0.8. Oh, that is 0.8. It just doesn't look right. It is right. How? Okay, I think I know why that keeps picking this. It's obnoxious, but... Okay, that's set right. Doop-a-doop. And one more. I think that's safe to put a via there, but I don't think I can put one here, so that'll make for some fun reflow. Oh boy. Okay, that's all the vias done. I will need to still put in an exposed copper pad on both of those so that I can get my iron on there. But I am inclined to get the SPI lines routed. KiCAD, you're on crack again. Oh, okay, good. I can just take this way up out. Perfect. I wasn't sure if this was going to be too close to the via. I don't actually care about the ground pin because it's connected down via the back, but the front, we do care about getting this out, but also not strangling about the power supply here, which is getting a little bit tight here, but we can move this down a bit in a moment. Yeah, with how this is routing out, I can just move these down. That'll be fine. Cool. That's one of them. Oop. I am going to look at the polygon pools next, actually, because I'm just realizing how messed up things are going to be for the power and ground here. Oh, this is going to be fun. So let's do a filled zone. For power ground. Nice. That was unintentionally quite so good. The other thing we'll need is to set this to a slightly higher priority. There we go. So that everything else stays out, because yikes. And let us put it on a slight fillet. Ah, I know why it's done that. That is the clearance, I think. Oh, no, sorry, this is the thermal. Thermal clearance is set just crazy. There we go. So if we now copy pasta that, technical term of course, we'll also set that to a ground. Ah, that's already looking so much better. Now, the main power pour in this area is actually for SPI ground, which is, of course, wrong here. So, let's pull that back down a bit. I'm going to say I want to go onto the smaller grid and pull that down. One more grid square. Honestly, Moonspark, sorry, Amy, that one depends on, how good the thickness matching of your board is. If the board is pretty damn accurately the right thickness, it'll be fine. If not better, especially if you can get hard gold flashing. But that's more expensive. Both because the thicker board is done by less fabs, and because hard gold flashing. So soldered connectors would be my go-to, because it's almost always cheaper. Ah, welcome back. So let us do another pour. This is going to be... oh, hang on, no. I want to edit this existing pour. No, this existing pour. There we go. I think it's the insert key. Yes, it is the insert key. That's a very interesting off-grid I've got going on there, isn't it? Huh. Oh, I think I know why too, because otherwise it goes too close to the edge of the board. Huh. Okay. So that's power and ground. How to route the other bits. Because we don't really have all that much board space. Like, this might look like it's oodles of space, but it really, really isn't when we start putting wires in and carving planes up. I'm actually almost tempted here to see if we can't maneuver these devices up just over the top of these caps so that there's more room between them. Let us see what we can do. So if we do that. Ouch! Glass fibers in your fingers is no good, Naz. Definitely sounds like you want to grab a file and get to work on cutting down the sharpness. I mean, even if it's not seeing many insertion cycles, it's just the fact that you've got fiberglass going in your fingers. Like, ow! And also really bad for your health. Well, okay, fairly bad for your health. Oh right, these pins are just friggin' huge. KiCAD, can I help you? Oh right, this is just slightly off grid because in millimetric. That's gonna be fun. I am going to do this to get around that problem. It's more... This is more traced than I'd like out the front here, but it'll be okay. Probably. Wow. Just wow. KiCAD, please. Glass is fiberglass as in circuit boards is not entirely. So it's the difference between it being a bulk material versus small strands. That's why it changes biological activity. If you breathe a glass fiber in, for example, it will cause damage to your lungs. It's great. And you also can't necessarily get the fibers out of your finger properly, so you can leave little bits in there because it breaks off really easily, which the body treats as a foreign body and starts doing bad things with, which is also why it's an irritant. That's why when you're handling fiberglass matting, you wear gloves, even. You wish it was as nice as asbestos, actually. Yeah, it's got some really nasty effects. So that's why it's a shame that they've used such a cheap fab. Yeah, I think I can now move this other one along a bit, which is nice. Excellent. That's looking way better. Let us now actually get the routing done. I'm holding off of the routing, sorry. Drop our track size down. Really want to go through the corner. Thank you. This is copy versus SPO, which is going to be a pain. Oh, that's going to be fun. I would definitely keep an eye on that, Naz. Because, yikes. I'm just trying to think at the moment, how on earth am I going to do this routing? Do you really want to add Tiny Go? Do you really? Because I'm pretty sure you don't. But go. I challenge you on that one, Steffi, but okay. And that's no fun, Naz. That's definitely no fun. It's just so little space. I'm just trying to work out how I'm gonna get that around here and also over to the processor. We're working with 2 at the moment. I'm gonna up this to 4 layer because it solves a massive headache I've got right now. Take her, Naz. The cost increase here should be pretty much negligible, because I'm going to be doing this through JLC PCB. Yeah, I mean, let's just quickly look. If I've got... yeah, I mean, like... Let's actually do the whole proper quote now. Let us put the board dimensions in, because we actually know them. So this is 54.3 and 24. So cheap as can be, versus so base price £5.40 versus £1.50. Either which way, this is just a drop in the bucket. I'm fine with this because I'll also then set for Enig and blue, or so. Oh, actually no, I was going to perhaps try white. We'll see. But if I do the same thing here, blue Enig, £26, £29. So this is going to not be that expensive to do as full now. The layer count is basically not factoring into the cost. What I now need to remember is what I've got on what layers. That's 3.3 volts. Let's duplicate that onto the inner layer 2. That was the 5 volts I've just copied. Should be at least. Where is that? Oh, probably V-bus. Oh, no, it was a ground. Oh, interesting. Oh, that's right, because I split the power and ground in a fun way. That's V-bus. Whoops. There we go. There should be a ground. Yeah, there's a ground. Let's just grab that real quick and put that as ground on inner 1. We then need to do the honors with... which one is that? That is the top side earth, that's right. Copied that wrong. Welcome, Matty. We are currently converting this board to be 4 layers because it's cheap enough and it solves a massive headache we've hit. there we go. We've got the stack up there. So it's just this one, I think, that's left to go. Why is there a no net on the bottom? Oh, that is because that's supposed to be inner 1 ground. Nice. This is SPIVCC on inner 2. So that should be power and ground on the inner layers. That's good. So now, now we can do the thing that was causing me headaches before. What we can do is we can now take copy here, CPO, etc., and put them onto inner planes and route them however we like, pretty much. We can really abuse the fact that we've got space between the wires and tear up the planes, because this area is pretty much dead in terms of needing the inner planes. We're just using it for signal routing, which is great. So, oh, that's not the thing I was trying to delete, KiCAD. Thank you. So, courtyard problems. It's fine, it's just a drunk courtyard. These two, U4 and 5, are flash chips. So, the idea is that in a moment we'll add a couple of user buttons over here to allow you to ask it to program either bitstream in the first or bitstream in the second, or whatever you're holding, to the target. So you can use this offline. Batch programming. And these are 64 megabit, I want to say. Yeah, 64 megabit flash devices. So, I'm going to start over here. Let's take this onto an inner layer. That'll do. Likewise, bring the right protect onto an inner layer. I'm not liking those wires. Those are a little bit too tight. There we go. Wants just a little bit of trace sticking out so that they etch cleanly. We'll do the same thing for hold. That's a kind of tiny wire. Yeah, it's my predefined size. Good. Oops. Trying to do V and managing to hit B. Go me. Now if we do the same thing over here... Ah, done it again. I'm not sure that that's actually all straight. I think that's on an angle. Yeah, it was on an angle. How do you mean the knee? I'll give it a look in just a second when KiCAD stops being stupid. There we go. Good enough. Make location. My IME decided to make that really annoying. I do not want adverts in the gear, thank you. As in here. Where it goes from straight to 45. Okay, yeah, no, I'm intentionally not doing that because I realized as I was doing that, pulling the traces out, I'm going to want them on grid on the inner layers. It'll make my life a bit easier. And that's all good. What I'm doing is I'm just making sure that the change in angle isn't happening right on the corner of the fire. Because that causes problems. Are you okay, KiCAD? Thanks, KiCAD. Let's do this then. Yeah, avoiding acid traps, exactly. That works. Let us then tie together the... Oh, right, the right protector I haven't actually hooked up yet. Properly. I'm thinking I might just hold those to high. Welcome back, Eston. I mean, I've had issues with vias even on modern day etch processes, just where the manufacturer's not used their best possible process. I'd just rather avoid all of that pain. Just realizing I should route this before I do the other bit. Yeah, it looks better too. Neat. KiCAD, please. That leaves the flash clock, which we can put on inner 2. Yeah. Come on. There we go. Nope, that's still not quite what I wanted. Thanks, KiCAD. Yeah, no, I'm not doing signal routing violations here. This is actually 2 different layers. This is more of a setup designed for more multiple layers, which is why the coloring is not the best for like just 2 inner layers. I might actually re-intermix them so that it's like a yellow, a lighter yellow and a lighter blue, and then a darker yellow and a darker blue. Because I think that would probably make it a bit easier anyway on the multi-layer stack up too. But like, I just haven't done it yet. That's where I was trying to route that. There we go. I know signal coupling and all of that stuff, but... Yes! Sign me up for one of those. Right, let us see what we need to do regards to the hold and write protect lines. I have a funny feeling that if I don't care about those functionalities, I can just hold them at a voltage and just let them be. So the write protect, yeah, I can just put it 3.3 volts. Oh yeah, contrast and colorblind, it's just a nightmare. This is actually why I've made it, the 8-layer stack up goes to purples, because I don't know of anybody who's got purple color blindness. So you've got red, yellow, blue, purple, purple, red. Dark blue, sorry, not red. Which should be about okay for an 8-layer board. And the 2 different purples are actually quite easy to distinguish, because you can see those easier, weirdly. Yeah, patterns, not just colors, would be a whole thing that would help. Because going past 8 layers, you get pretty strapped for unique colors that you can turn the traces that are still easily distinguished. Like, I think the next color choice after I've got to go to is orange. Which, yeah, It'll be fine, but it's not great. I'm just intentionally avoiding green because color blindness with the red layers. Yeah, that's fair, it does. I don't think I need to deal with hold mode. I think I can just leave this pinned high and just don't care. Is that reasonable? Because I control the clocking sequence anyway. Does that make sense to anybody? Eston? Does? Atty? I don't think I need this hold pin. I think I can just pin it at 3.3 volts and forget it. Just like I'm going to do for the right protection. Cool. My only other question then is, would you suggest I put this through a 10k ohm resistor just in case someone goes and puts the chip in QSPI mode? Okay. Let us change this. It becomes an output in QSPI. That's why I am suggesting resistor and resistor, just so that we won't get shorting and dead chips. I really want to get the part information on the bottom half of this. Because that's not readable. KiCAD. Kinda love you, but I also kinda hate you. Oh, welcome, Lethal Bit. Yeah. Came on like the perfect song for it to be chill stream too. Yes, do please give Aki hugs. She needs them. She's had a rough week, to put it mildly. Hihi Aki desu. That's cute. The font for there is a little bit difficult to read. She's just adorably cute, isn't she? Oh, now it wants to let me flip the KiCAD. Japanese is awesome. I mean, it's never too late, to be fair. I do as well. Aki and I might be able to help you on that one. But yeah, that is definitely a struggle. I mean, I still can't read katakana. I can only read hiragana and some very few kanji. So, you know, you're in good company. Let us annotate this. Flip back to the board and pull those changes. Why? Oh, right, yeah, that's, we know about that. This needs a little bit more work. Yeah, there's a lot of them. It's bad. Aki got me the Genki books. One of the best things I've ever had to read is the Genki books, because they're just so well written. That's a mood. I honestly recommend the Genki books in this regards, Steffi. I have terrible memory as well, and as you have just borne witness, I can read Japanese as a result of those books. I'm not great at it, but I can do it. Which is pretty good. It's a mix of how they do the teaching. Yeah, it's a full lesson thing. It's kind of awesome. I'm gonna move this down to the corner. And the workbooks are great. Heh. Okay, flipping that. That's, yeah, a whole mood. So many parts in such a small space. Ah. Oh. That can't even go there. Whoops. That has to go, like, here. At closest. That's... Yeah, can't go under there. Ah. Yep. And this is going to be a fun board to assemble. Lethal bit, Aki dear, you are amazing. And I love you so damn much. Yes, I'm getting mushy on stream. No, I'm not sorry. You're amazing. No being mean to yourself. You've already had a bad enough week. Compliments are allowed. Let's see how bad that looks. I don't love it, I don't hate it. What annoys me is I've not managed to line it up so that, yeah, because I've lined it up to the wrong marker. Nope, I don't want to edit the zone, I want to grab the silk screen. There we go. That's better. You can totally read that, right? That's totally understandable silkscreen. What axis do I want to rotate this around? No. No. That one, there we go. I don't have room for more flash, and you know it. I'm already struggle busting with this flash. Come on. stack them. No, love, no. I am not stacking Flash. Not this kind. If it had leads, then maybe. Yeah, I'm gonna actually rotate this. No, I'm not. I don't have room to rotate that round. Grr. Ah. Sure. Sure. If we're gonna go with let's give Rachel the maximum amount of pain with this board, sure. What, with it being 2-layer? Oh. This. Oh, there was nothing wrong with it, I just didn't like how it was looking. I was thinking this would be a little bit nicer with how the signal has to hop on out. And it does look a little bit nicer, honestly. I'm even tempted to go as far as, like, moving this so that it's here. But, like, why would I do that? I'm gonna just drop the plane more. No point. Talking of the planes, how are we doing? That's not bad. That's honestly not bad. That's chopped up way less than I thought it would be. I still need to, of course, route these to the micro. That's gonna be fun. Yeah, it really does. The hard part with this, oh, that's definitely not the layer I want that on. Is going to be that I've got to somehow cross these over, kind of like that. So that's now off-grid and a bit tight. So I've got to change the layer SPO here is being routed on to make it into here. Actually, yeah, no, I have to. Yeah, I have to do it this way because I can't root on the red. I can't root on the top layer here, otherwise I'm gonna kill power, which is bad. This is going to be interesting. That's all I can say. This is going to be interesting. I'm actually going to change the flash clock layer here. I'm going to put it on this layer for reasons. I need to move this back. Let's put it like there for right now. Because I've got room in here, I think, for a fire, probably. They're pretty smashing huge fires, but... Whoa! No KiCAD, that's what I was wanting, there we go. Yeah, and then I can then use this inner layer like this. Oh good, there is room for the fire. Just. Oh, that makes me happier. I can put that there. That'll be good. That doesn't fill me with horror, at least. I've done worse. They really didn't think about the interface, did they? It would be really nice if, like, this pad, instead of being one of the write protect type things, was actually SPIFo. Because then I'd actually have an approximately matched length matched bus, but I don't, so hopefully that's not going to be too much of a problem. Still have to do the chip selects. That's going to be fun. It's like, it's almost as if that's what their thinking was. Apparently we've got a power problem there. Oh yeah, we've also got to redo some stuff here because we KiCADified this part so that I can hand solder it, and it means that the wires are now embedded in the pads, which we don't want. But we can move the diode, and that'll allow us to move this wire. We can move this resistor a bit, we can then move that wire, so we can salvage that. I'm just looking at the chip selects and going, why did I put these this way around? And also, how am I getting a chip select all the way to there? I'm tempted to actually swap the chip selects out for like pins 8 and 9 here. Let's see what's on pins 8 and 9. PE 0 and 1. Perfect. Let's move those pins. That doesn't exist, that doesn't exist, because we've removed those. So we said PE 0 and 1. Now, M, not G. Like, why can't I move this? Oh. Wrong way to try and move it. PE0 is pin 9. We need that in our heads nice and fresh because pin 9 is easier to get to for this one, and then pin 8 is easier to get to for this one. So PE0 for chip select 2. Unless I go and, you know, switch the 2 chips around, but then that means a lot of moving other stuff, which I'm not about to do. Oh, and you also need to revisit the power section here, because this isn't actually complete. That's a good point. So, let us do that. Ah, that's better. Because what I can now do is I can probably bring these out on an inner layer through here, up and around to the 2 chips. And I'm not going to feel too bad about doing that. Because I can then sneak in here on an inner layer. So if we go for inner 2 for this, cuts up the power planes, but we don't really care because we've got the outer power planes to keep us good. Yeah, that'll work. Nope, that's what we want. There we go. That's pretty slick. Cool. Alright, for that chip select I don't want to come out that far. Haha. Let us rip that bit up again. Whoa! No KiCAD, that's not what we want. Yes, clearly. the wire down a little bit just so that there's room for shenanigans. That way, thank you. There we go. I don't hate it. That's a good start. Alright, let us put the wire in for this one. Neat. I think that's our flash all hooked up. That should leave 2 unrouted. Where's the second unrouted? I know about 1. Ah, there's the other one. Okay, nice big track. I think a wire basically right there will do perfectly. Yeah, that's pretty good. So that leaves just this little puzzle. Why am I not getting 3.3 volts where I need it? Oh, okay, I know why. Well, now that we're going with multiple inner layers, I can do a plop onto an inner layer. I think that should probably actually needs to be inner 2. And we'll come over as far as the plane. Looks good. No unrouted. So that leaves us with 2 user switches that we need to put in. And some wires that need fixing. There's the first wire. Did I lock this part or something? No, I've not locked the part. Apparently I just can't move the part. KiCAD? Why can't I move the part? Well, we'll do this. This will be the easy way. Then let us move the diode out to like there. That'll do. Can still give it power cleanly. That's a good idea, dear. That works. So that leaves us just with the 2 user switches. Who wants to see me use big chonkers, or who wants to see me go and find some nice small tactile switches? Because I've got chonkers. Those are easy. Oh, Steffi, you know the chonk I'm referring to as well. Those chonkers. Okay, for the rest of the stream, I will quickly add on 2 user buttons. Well, actually 1 user button, because they're that big. I'm not going to put both of them on quite yet. Okay, that is even more chunky than I was thinking. No, the other ones. There's a reason I said that only you know what these chonkers are. Okay. That would be obscene. I love it and I hate it at the same time. Because the board's so much smaller than the switches are. There'd have to be side mount switches or something ridiculous. But damn if they would be the nicest feeling user switches you've ever felt. Ah. You might have broken me very slightly. I'm trying to remember... Oh, it might actually be in device. I'm trying to remember where the switch thing is. There's a nice switch part you can plonk in. Another step towards truly cursed. Thanks. God, this has taken longer than I thought it would. Hope we've got time for the other board. Ah, they're not in the device. Interesting. I know there's a search box. I'm trying to remember what they're called so I can search them. Is it SW_? Oh, okay, yeah, maybe. Yes, thank you, dear. You are exactly correct. Now, the question is, did I put these into my main set of libraries, my R... else... Agreed. Aki to the rescue. I approve. I did not put them into this. Ah, okay. Did I put them into this package? No. No, I did not. So, we need to go and fix that one. Let me quickly do a copy pasta. There we go. I'm not going to hook it up to anything, I'm just going to throw it into the board, just so you can see how huge the switch is. There we go. There's a chunker of a switch, which, that's just huge. I love it. I hate it. I actually don't have room for two if I do that, though. Oh, okay, we're gonna go and look for some smaller ones just because... Yikes. It's a switch. It's a good switch too, actually. It's quite satisfying. It's big. It's very big. Esden, if you're still watching, I can't actually put them on the back. What is the switch that you're using on, like, Glasgow? And do you think it would be a good fit for this? Because I'd ideally like to put a couple of switches here. Indeed. Let's get rid of that, because it's obviously not the right switch for this job. Thank you. Let's have a look and see. That looks kind of cute. It's definitely more in line with what I was thinking. And apparently there's... a login to download. Okay, that's fair. Let's quickly satisfy that. See what we can download. Step. Wow, there's a lot of options. Huh. I'm guessing it's this one. Maybe. But also I'll quickly check and see if this is already in library. Because if it is, then I'm not making another footprint on the stream today. For this board. All the fun footprint stuff will actually be in the other part of the stream. Apparently it forgot what schematic it was supposed to be pulling. There we go. So this is... Is there a way to search this? No. There is no switch library. Ah, there we go. Button switch, SMD. Huh. Interesting. We'll have to come back to those. This does not look like it's just in library. Aww. Yeah. Fine, we're doing another one. yeah, that's quite tiny. Very nice. Quite squat off the board. Yes, I know about the whole... Yeah. Let's pull out the step file. Which is this one. And this is... this version, I think? With boss? -B? Part number descriptions are probably at the top, aren't they? Yep, with boss. Perfect. That'll help with locating them on the board. I'm okay with that. And it's not too big a hole. Yeah, the boss puts a hole in the board, but that's quite a small hole, and I'm doing it in an area where I've got nothing else on the board. So that's okay. I'm just trying to work out how we're gonna... That measurement there is really great. That helps a lot, because I now know that that's quite oversized. Although we could even go as far as 1.8 just so that it's... But, I'm trying to work out, like, how far under does the metal contact go? It doesn't say. Because this is just a preferred pad layout, and that ends badly for me. Because they're only saying put 0.1mm extra on the front there, which is way too little. So this is going to be Rachel's hot air solderables. KiCAD libraries, there we go. Button SMD. I think that'll work as a naming convention, except it's button hyphen. Global. New footprint. And this footprint is going to be for that. Let's not forget to put those in the right place the next time, well, this time around. So these are SMD round direct. Let's put that on the other screen so that I can see it. They are advocating pad size Y to be 1.7, 1.8. That's 0.2 millimeters top and bottom. And then the X, they're saying 1.1. I'm saying that's going to be too small by quite a bit. Hang on, no, they're saying they're saying 0.8 millimeter pad. I'm going to say 1.2. We're going to add 0.4 onto the front, so we've got a 0.5 millimeter soldering pad. Should be about right. And I need to skip this song because I know it's got lyrics. Now, this is going to be too big for round rect. Let's do that. So they are saying, no, it's 1.3, not that. Then the pad center that they've got is 0.8, but we're going, maths is hard. 1.2 is 0.6. Sorry, trying to figure out where the center of the pad is so that we can correctly offset the X position and just easily copy paste it into the right spot there. That doesn't seem right. Because I forgot that it's add, not subtract. There we go. So in theory, if I go from here to here, 2.6, that matches the tech drawing. Then we want a non-pad hole. We just want a hole. How do I do that? Help! How add hole? I guess maybe that it's something I can do in here. Ah, here we go. Yeah. Thank you, dear. You're the best. Yeah. I've dealt with worse. There we go. That's the boss. See, that's where I have to, well, had to disagree. I need to now play with it more, but, like, it used to be bad. Because they didn't used to have toolbars, etc. It was hyper, ultra minimalist to a point where it just hurt to use. But I am aware that they have been fixing that. These want to be 2.5mm tall. That's 1.25. Oh, right. I was editing the wrong dimension. It's this dimension. Congrats! Even though it was pain and misery, that is still excellent news. So that's the part. How do I mark pin 1 on this? Is it I just put a line from like here all the way down to the edge of the pad here? Okay. Okay, yeah, technically they're non-polar parts, so... Okay. Helps if I'm on the silk layer when I'm doing this. Let's do that. And... that. That'll be what the board looks like. Then we can do a courtyard real quick. Oh, before I do that though, let us correct the pad clearance and solder mask clearance. Oh, shush. Yeah, you did. Pretty sure it's not, but I'll check. Because we might as well just get that loaded. Cool.
Un croissant, s'il vous plaît. Croissant.
That is because that's exactly how far wrong it was, Obliterous. Oh yeah, you are correct, Steffi, thank you. I'm just looking at the fact that the part is currently embedded in the board. That is a Z offset, but not that much of a Z offset. Shit. Derpy McDerp there. Let's just do that. There we go. I'm pretty certain that that was embedded. Oh no, you're right. Okay. Cool. That should be... yeah, that's now on grid like it should be. Cool. So, our courtyard. 1, 2, 3. 1, 2, 3. Looks good. Now let's bring in the silk screen. Oh, because I got the fab layer off, that's why. Whoopsie. Cool. Those are the wrong way up. Delightful. So we can now re-footprint this to this. There we go. And let's find some pins down that side that we can put these on. Pins 47 and 48 look perfect. So let's so much open. PB2 and 3. Excellent. Should be nice and nostalgic for Obliterous. Yup. Exactly, Obliterous. So I'm going to put that text, like, there. Oh. Trying to get a wire and flipping it again in X. It's great. Just realizing I'm going to want pull-ups on this, so I need some space for them. Actually, I think I want pull-downs, and these switches connect us to power. Because then the pull-downs can go on the bottom side of the board for extra compactness, and we'll get a pulse, a positive going pulse when the button's pressed. How does that sound for everyone? Excellent. Let's give this a value of 10k and reformat this so that it's less awful. This is why this community is so awesome. We just solve each other's problems in just the best of ways. That's looking off-grid. Yeah, this is... This is all off-grid. Crunch, there goes my resistor. Need to go this way by a... This is a good song. Off the major grid, and that would cause a DRC error. I guess we should probably add the kind of switch here as the value of this. That's all kinds of in the way. It works. I don't love it, but it works. Let's see what that now looks like on the board. Ah, I forgot to assign some footprints. Whoopsies. Try F, woman. I'm bad at this sometimes. Oh, no, that's a bit big. 0603. Try that. Oh yeah, this is gonna be comfy. Going and sorting food, love. Good thing. Good girl. Let's put that about there, because it's not then too close to the hole. And we're not cutting planes up too badly. That's how to live dangerously with your silk screen, everyone. I'm putting that above, not below. I mean, I was right on the edge of the board, so like, it doesn't really matter at that point. It's gonna get sliced up somehow. I know it's not, but I set the courtyard to approximately align with where the silkscreen wants to be for this device. See? Although, I guess we could put this, we could put them down the sides. That actually would look really good. In which case, we can go much closer. Because we're not then going to be interfering with solder pads. Yeah, that's nice. Oh, right, yes. Oops. Time ticked. Sorry, Steffi. Yes. Fair point. At the sometimes. KiCAD. There we go. Well, that's actually the user switch is done. We're, save for fixing a little tiny bit of silkscreen here, because these are a little bit close, I think we've actually managed to finish this board at last. Yay! So let's remove that note. Let us just double check that we're happy with things here. So, doesn't matter that those will be hidden by the, yeah. I don't mind that these are going to be hidden by the Blackmagic probe, because they shouldn't be being used when you're trying to reprogram this chip anyway, so although we can always like put a spatula or something made of wood under and press the buttons that way, or a plastic pokey thing. The buttons are for telling this board to write the contents of one of these two, depending on which one of these two are pressed, to the target. Yeah, this is comfy. And so many caps on the backside. This board's great. I love this. This is... It's nice and small and just fits. Just fits. The only thing I've got to do that I've just noticed I haven't yet done, I've got to put two pads here so I can get at the back sides of these. No, I didn't. I just turned this into non-ray traced so that you'd be happier. I actually still prefer the ray trace view. Oh, right, we need to very quickly... Do we fix this courtyard? Nah, it can stay broken for the moment. I'll fix it later. We don't care about the adhesive layers either, because we're not using them. So this is F-mask. What? What is driving you crazy? Oh. Oh, I'm sorry. Oh, okay, fine then. I'll go and fix it in a moment. That feels pretty good. Let's just check. Yeah, that's okay. We now have to move some silkscreen, but we've got room to, so that's fine. F silk. Grab this. That looks good. And let's do the same thing on these before I put the mask expansion in. I will fix it in a moment. Don't worry, honey bunny. Oh, that actually honestly doesn't matter. I understand that your brain says no, but yeah, it actually doesn't hurt anything for it to be like it is. Let's just double check. That's good. At some point we apparently lost the silkscreen for this. Whoops. Oh, no, it's underneath. There it is. Okay. This looks good. Transistor has its silkscreen under it, which is fine. I mean, I guess I could put it up here, but like... functionally it's identical, because the only time you need to know that it's Q1 is when you're putting it on. But, like, this is... this is what it would look like with it not under. I'm gonna actually put it back under, because, like, yeah, it's fine there. Let's just double check the bottom side. I haven't got any designators in parts. This is a good start. Cool. Right, let's fix this for you. which is in this library at the moment, because I need to do it better. There we go. Let's just quickly update the footprint here as well. I'm glad that I have managed to fix your physical pain to a piece of line work on the board. The last thing I'm going to do here is fix this connector, because this has currently still got a mounting pin. Yeah, well, you know. Oh, right, I edited completely the wrong bit there. It's that. Because it's the connected. Yes, I was trying to delete that bit of text. There we go. That'll now make the DLC happy at us, because we're not putting the pins in, so it's fine. And it doesn't error anymore. Yay! So, I'm not sure what's causing that warning. Also, these are now all mixed, because I'm bad like that. What rule is causing Let's actually see what happens if we put that down to 0, because I think that's what it's complaining about. Yeah, we lose the solder mask expansion on this connector, which is bad. Oh, that's not even the right connector anymore. Have I done a version of this already? Is it in my library? Maybe. Try pin header. 2x5? Yeah. Let us update this and rejoice in the round rect. Does it think this is now backwards? Yes, apparently it did. Great. Indeed. Bollocks, you're right. It's from the library too. Oh, crap, it's not the odd even version, that's probably why. I bet if we convert it to... this one? One, two, three, four... No, it is! It is odd even. Grumble, grumble, grumble. Odd even. Matches. I think I know exactly what's going on here. I think that'll now work right. Let me just quickly undo a couple of things. There we go. What happened was we'd done a bodge to make it work with the other footprint. We had the connector backwards, if you will, in the schematic. And this one actually has everything right, so that it doesn't have to be backwards in the schematic. Although, I've just realized this is actually the footprint for it being one of those, which is wrong. Because that's not the part that we actually want on that part of the board. It's the mating connector for that. For JTAG. So that we can then reverse mount a Blackmagic probe to the board. Because that's a thing. Let us pull open the library. And copy. Paste. Oh, no, it was save as. There we go. The pin socket, it calls it. Let us grab the pin socket. And I'm betting when I open this, we're going to find the pins are all flipped, which is why we'd done what we'd done. Yep, the pins are all flipped. That's why we did what we did. It's so that when you, if you've got pin 1 of one side as like a ground, pin 1 of the other side is also that ground, because it physically is mirrored when connected together. So it actually makes perfect sense. But is very annoying. Better. There we go. No, I actually do need to fix this properly. I need to actually mirror this connector, but it's not going to be hard to do. Because what they've done actually makes a lot of sense, and does help with mechanical design a lot. I'm just grabbing a couple of bits of information that I'm gonna want, like that. It's called socket strip. Steffi should go to bed. Ah. Too gay to sleep. Yep. I agree, Aki. Fair enough then. Sleep well. Oh, don't worry, once you've got someone nice and comfortable to sleep with in bed, you get used to it very fast. Some of the best sleep I've ever had that way. Yes, I'm being mushy again. Nope, I am not sorry. Okay, this should now... That looks all good. Welcome back, Aki. I was being mushy about some of the best sleep ever is once you've found someone who you're nice and comfy with in bed, getting to sleep with them in bed. Mm-hmm. So this is now this. Mm-hmm. obliterous. Ah. Eh. I don't know, you figure it out. As you go, you just figure it out. There we go, that fixes those tracks. Sleep well. There we go. There's the solderable footprint in all of its glory, and now we don't have anything violating the round rect rules, including with the solder mask expansion, etc. We still have to fix this footprint. Oh, we still have to fix this footprint. I really want to get to the point I can hit the button that's center fab, pretty much. Come on, let's get this done. This is in oh, I might already have fixed this one. Maybe. Ah, no, I've got an exposed pad version in my library. Ha ha ha. Okay. Round rect will rule forever, yes. Oh, this is in my personal library at the moment because it was never finished. So let us add to the silkscreen layer some nice markings for where the edge of the chip is. Nice. There's two of them. And then this one. Pardon me. I think looks like that. Oh, okay, sure. So, that's what you're saying. Okay, that actually is a really quite nice footprint. I like it. Steffi, go to bed. Yes, I know. I know. There you go. It's all nice and pin one-y. I was already imagining that. Nyai nyai. Welcome back, Amy. So now we've got that done. Now the board is action. Let us do this, the Gerbers. Hey, it's not complaining anymore. What do you know? So, because most fabs don't actually yet support X2, we'll uncheck that. We'll also enable subtract solder mask. Shouldn't do anything. I like the Protel extensions because then I actually know what the hell's what when I go to then put everything into the stack up to center fab. Yes. 90-degree header connect. J1 here. It's just a shrouded pin header. There's no particular special name for them. It's just a shrouded pin header. Now, we want the 4 copper layers, pastes, silkscreen, mask. We don't have anything on drawings, comments, or eco that we care about. Obviously we need the edge cuts so that we have the routable board. And I think that actually is about right. That should about do us. The other bit we will want is... Okay, it's almost like I preset this at some point. I always have my normal plated through holes and non-plated through holes in the same Excelion drill file. I've never had a fab complain about this. I think the ones that actually care split it back out for you. And I've never really seen use root command actually work. I always use the alternate drill mode, and I've never had a fab complain. Besides which, GerbV, which is what many of the fabs actually use to inspect Gerbers, does not support the root command. Yay! So, this is my preferred settings. We'll generate drills. Should be good to go. Now, this is where things get fun. And apparently my schematic overlay broke again. Wow. OBS problems. So, what we want to do is go find SPIFlashProgrammer board Gerber. This is the mess that it gives you. Now, I'm actually going to do a little tiny bit of maintenance here. I've moved all the files into the directory called KiCAD. I'm then going to symlink back in the cleaned up names of the files, so that this is a little bit easier to kind of explain. So that is the bottom copper. Top copper. Inner one. Which is that. There's the other inner copper layer. That's a broken symlink. I know why. There we go. I got a file extension wrong in the symlinking command. We then want the silkscreen. So that's the top silkscreen. Load. There's the bottom silkscreen. Now, for some reason, it likes to generate edge cuts as GM1, but most fabs actually prefer GKO. Gerber something outline. Cut outline, I guess? The drills file, they actually tend to prefer XLN. Yeah, cuts with a K. For some reason, KiCAD likes GBP and GTP as the paste layers, but it usually is called cream, so it's GBC, GTC. And that should about do us. Our really tiny board relative to how zoomed out I was. Heh, that's fun. So, that's the only way I'm going to be able to show it all. Oh, it may originally have been keep out. I mean, this is a standard, in quotes, that has been permuted over the years, so... God help you, you know. Those are our two inner layers. We can see that they appear to align nicely with everything else running on the board. I'm going to put the drills at the top so that we can see all the holes that the board will have. We then have the bottom copper and top copper, which is all looking quite nice. So if I turn those off, we then have the cream. There we go, now you can see the cream layer properly. And in theory, that's not really showing the detail I'm trying to show. Oh, no, that's right. This is just showing where the pad is, basically. And then there's also the... where is my solder mask gone? GBS. I forgot to symlink in the GBS and GTS. Apparently... yeah. Wonderful thing though is I can easily load the extra layers. I've just done the honors putting the symlinks in. Why is it resizing like that? There's nothing down there, surely. There shouldn't be anything down there. There we go. That's looking far better. There's the S. There's your solder mask layer. And then silkscreen and paste. And if we do the same thing for the bottom, we've got the solder mask, the paste. No, where's the paste gone? There. And then the silkscreen. And then finally the GKO, I tend to put near the top, the master outline. Wow, that scrolled really badly. And I'm happy that this all appears to be aligning properly. I don't see any holes that shouldn't be where they are. So, we can save a project from this. Good point, thank you. Otherwise I'm going to hurt myself, and nobody really wants that. Oh, come on, let me... Fine, we'll grab the edge cuts layer itself, and then we can perhaps... Yay, there we go. How much of a round do I want here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Half a millimeter? That's probably about right, right? If I can get a hold of the friggin' line. Now, I'm gonna round it all the way out to a millimeter. Because I can. Yeah, that looks good. Hey, let me grab it, thank you. There's that. That looks good. Let's just quickly regenerate the main Gerbers. Yeah, do a refill. Would have helped if I'd have done that. And then if we re-enable the copper, top and bottom will do quite nicely, and we do a reload. Oh, I know what's happened here. Okay. I forgot to change where KiCAD would put the files out to. So that's entirely my fault. There we go. Voila! That's actually pretty satisfying. Excellent. So what we can now do is... where's OBS when you need OBS? We actually don't want my left screen showing here. Okay, so this is how I did all the sim linking. What we now want to do is take all of these files and make an archive out of them. So we want to do compression level 9. Actually, I have build Gerber. Okay, there we go. I have a thing I already know how to do, as it were. Interestingly enough, that would actually build a broken 4-layer Gerber stack up, but okay. Yeah, because I don't want to put the creams in. Oh, actually, no, I do want to put the creams in this case. So that's a whole pile of bash magic. What I've just done there is I had the shell expand out the string G, B, L, G, B, O, G, B, S, etc. and build all of those different strings for me. Squirrely brace syntax in Bash is just awesome. So with that done, we can now swap over to a web browser real quick and we can see how what's his name? JLC is going to look at this for us and so if we take kill that one, we'll take this one, upload the Gerber, which is in here now. Let's actually check that it's going to actually cost what we expect it to. Or if they're like, you've done something weird. Okay. Oh, they've determined that it is the size that we thought it was. Excellent. We do want it blue. Thank you. And enig. And I don't want the order number on the board for aesthetics, basically. That looks great. It's a little bit more expensive because I've asked them to take the order number off, but that's fine. I will get that ordered off stream for obvious reasons. So I'm really happy with how that's gone. Let us quickly close down normal KiCAD. Let's fire up the nightly. KiCAD nightly. And I want to make a new project. So I really wish it would stop doing that. That's not KiCAD's fault, by the way. That's actually my desktop environment doing dumb things. Or actually, sorry, no, the GNOME file open dialog. Project name. Project names are always really hard. I don't love it, but like maybe. Anybody got any better ideas for a project name? That's a fair answer. Well, I guess for right now we can do that and we can come back and figure out a better name later. So random name generator might not be a bad idea in this case, because yeah, yikes. Just setting OBS back up because it's like I don't know where things are. There we go. So, we need the mating part. Now, this is going to be the interesting bit. I've never played with the mating part for the connector I like to use. So we want a... where's the connectors category gone? Connectors and cable. Plug and socket connections, I think, is the right category. Nope, that was not the one I wanted to click on. Whoops. Grr. We'll just do it this way. There we go. Plug and socket. Where's plug and socket gone? There we go. Okay. I don't want to have to go by like product ranges. That would suck. This, I guess, is the one we want. We want micro B. 2.0, because we don't have a 3.0 connector on the board. And really, I can't move this to the top? What bullshit is this? Let's do each and cut tape, because we don't actually care about full reel and that kind of thing. No delivery surcharges. It'd be really nice if I could put the friggin' thing at the top here. We'll include that. Now, the connector I tend to use is obviously a receptacle. We are wanting the plug part. This is actually already a good sign that we're seeing plugs. There's not very many of them. Oh, fun. I don't even quite. I'm just checking that I've got enough music in my playlist. Probably. Right. No longer manufactured. That's all kinds of funky. And apparently it's surface mount. How on earth does that work? Okay, I think we might want to go about this a slightly different way then. We might want a micro B to micro B cable. That's just a really short one. And let the adapter sit kind of in line in the cables. Because this is gonna be all kinds of headache. It's designed as a test connector. Okay. Let us look for Type C. Receptacles. I'm hesitant to go and click on the larger one. Mini B was worse. I mean, the ones that you've seen on the keyboard are really hard to destroy. I've used them on quite a few projects and they are brutally resilient. The board will tear apart before the connector. Like, damn. The other thing I'm going to do is, on a new tab, we're going to look at cables. I was hoping there was an easy way to find USB cables. Pre-made cable assemblies would be really great. God, you can get like SAS assemblies, but not a USB one. I've got to think these are not that common. Which is why I was hoping to do it using a connector. Fair enough, Obliterous. Take care. My best to your wife as well. So there's an on-the-go cable. Okay, I guess that works. Kind of expensive. Does CPC have anything saner? Yes. And for a much better price. We don't need 2 meters of cable though. So I'm looking for a micro B to micro B cable. Because then we can use the same connector we've used on the keyboard on the adapter board as well, and just have a small cable that fits into both using the same connector. Which saves me quite a few headaches, because I actually need to set some resistor stuff up in the on the adapter, which is why I can't use a Type A. Oh, this isn't too bad. There are 14 of these cables available on CPC Farnell at a reasonable price. If we sort these by price, I mean, the shortest one is the cheapest one is 2 meters, 1 meter cable. Oh, that's A to B. I mean, it will work, and it's pro signal, so it's reasonable quality. So I mean, that is our cable headache figured out, although it's a bit long. No, micro B actually points at being either device or host. Thanks to the on-the-go spec. No, your phone, which uses a micro B connector, is allowed to be a host. Directly. That is in the spec. That is not a spec violation, unlike A to A cables. I just don't think it ever really caught on with micro B. Whereas with Type C, everybody's like, I can connect everything to everything! Which is horrifying in many respects, but also, it's a nice change. So, Aki, any chance you could dig up those Type C connectors you originally linked me like months ago? Don't worry if you can't. I have a funny feeling this Hyros one was one of them, so... I just have to go hunting for a datasheet because it's not on Farnell. Grab that number. I probably could search through our links then and find it, but I don't think anybody wants to sit through me doing that. How can I... Oh my goodness. Fine, Hyros, fine, but you've technically broken the law with that one. Oh hey, we can pull a step file. Nice. Excellent. Oh, this is going to be a good connector to use actually, because this mounts through the board. Yay! Center mount through the board. Although the pins going through the board aren't that long, to be fair, but I mean, anything is better than nothing. Oh, actually, that wasn't too hard to find them. There's another of them. The Hyros connector we've got open. That one, and that one. Not too lost to Telegram. Now this is a USB 3.11, which means that we'd have to do some adapting. And it also means the pin pitch is far finer. This is quite expensive, so I'm going to ignore that one. This one's decent for price, and it's got the nice through-board connection parts, but it is also a full 3.1. This one looks interesting, but its datasheet is also missing, and it's also a full 3.1. This has got a datasheet at least. This looks nifty, and it's not too expensive. Yes, that is totally a datasheet for it. That's not helpful. Let's see. So that's the high-rise one. Let us find this TE one. I don't know what their website is, so give me a second to find them. Such a descriptive part number. Come on. Hit enter. Go. This looks promising. This is the... I don't know which of these it is. That's thoroughly unhelpful of them. I'm gonna guess it's the C version. Really? That's objectionable. Yeah, everything is log in. Oh, no, or continuous guest. Okay. That's not so bad. Okay, now it's not going to ask me. That's better. That's the one we've just pulled off Farnell. That was the unhelpful one. I want to see the drawing? Ah, there we go. Hey! That's not bad. How deep is this? This goes, not very far into the board as well. That seems to be a theme with these. Ah, and there is also a whole series of through-hole pins underneath the part. That's in this section here. Okay. Is there a pin out? Pin outs would be good. That's a good option. I approve. This has a pin out if I recall correctly. Yeah, there we go. It does pin assignments here. Nice! Awesome. And there's the other pin out there. That's good. So yes, this has got pin outs at least. The TE one, not so much. Also, hilarious that this was done on Windows and there's the file name is the path on their project drive. That's a faux pas. This is the Verth Electronic. Ooh, that's not terrible. And that's another mid mount. And it's a pin assignment. Oh, this is quite nice actually. How long are the pins that go through the board? It doesn't actually say. We know we can get the step file for this one. Oh, 1.6 millimeters. Oh, nice. Okay. Ooh. Left mid drawing on the first page. Oh shit, there it is. Huh. Awesome. 1.6 millimeters, which is the board thickness. That's excellent. Did this one say? Yes, it did. 0.68, which is a little bit below what we would like, but it would work. I'm really judging these based on how far through the board they'll protrude, because that really gives us mechanical strength rigidity. Yeah, this one doesn't protrude far enough. Really makes me want to use this one. Oh, minimum order quantity though. Oof. Oof. Yeah, I could. I don't have any potting compounds, but I could. I'm just looking at the minimum order quantity and going, yeah, I don't need that many of this connector. Yikes. Oh, I found 2 products though. Ah, there is a version with it less. There we go. Good evening, -8 mate. I am doing well. We are currently trying to find the connectors for the board I'm about to use KiCAD nightly on. This is looking exactly what I want, and it doesn't cost an arm and a leg. Great. Let us use this one. So, have they reintroduced that bug? No, they fixed that bug! Yay! Oh, I do need to alter some paths. The built-in libraries are decent if you have hot air reflow available. I've been building my own as well, which are designed for being able to be used for both reflow and iron soldering. They're known as the Rachel Hot Air and Iron Solderables. And you can find them on my GitHub account. There's not too many things in there yet, but I'm working on building it out as we go. Where did I put the KiCAD Nightly bits? Give me a second. Let me give you a link to my solderables. It is this library that you want to pull, because then you can then pull all the submodules and get all the footprints. Now. Come on, there we go. Chrome being stupid. Yeah, I thought so. It's in KiCAD Nightly. Perfect. So everywhere I've got user share KiCAD, I just need to change this for not that. That. Normal Nightly users wouldn't have to do this. This is just because it's imported all of my stuff from normal. So with that done, oops. I have made a mistake in the library nightly, haven't I? Yes, I did. Okay, we've got a thing I need to fix for the next nightly. That's gonna be fun. I think the template is in there as well. Yeah, it is. Packaging is hard. Hey, there we go. Excellent. Now it's using the right set of footprints. So, while I have got my hand solderers available, and we will use the USB one, these are in the old format. So, for this... Actually, no, we are going to do that. We're going to edit into the old style library here. New footprint. Shouldn't cause a conversion. Which is not micro. USB Type-C. Well, USB 3.1 Type-C in PCB. I've got to fix the name of the other one at some point, but you know. Now, first thing I'm going to do on the fab layer here is oh hey, they've introduced a proper rectangle tool. Ha! Awesome. I actually think I need to use the old style tool, but we want let's just lay down some lines. Oh, that's a nice addition. Line length. You don't have to guess. Oh. That's just awesome. I am learning with everybody else here, by the way. I've not used the nightly build yet. I just got it working. Oh, this is also improved. Hey, that's awesome. This dialogue needed work, so this makes me so happy. Ah! Happy girl sounds. Yeah, so this is 9.65 millimeters wide. Call that 9.7. Ah, you want to look at my previous streams. I've done a lot of soldering of those. My main stream, which we're going to do next Saturday as well, is a building and designing a keyboard from scratch. 6-layer board, full RGB backlighting, but without flicker, with a quite unique key scan matrix system, and all of the parts on the board that are the drivers, the processor, the decoders in the column drive, the logic level converter, are all QFN. And there's quite a few of them. Oof. At least it didn't go bang. I'm also noticing that this dialog is automatically updating this field as you tab out with the actual value that what you've expression actually calculates out to. That's fantastic. Yes. How long is this footprint? It is 10 millimeters long. Awesome. So, ±5. Yes, just keep hitting the 5 key, woman. Yep. So that is the outline of this connector. Now, oh, I'm not yet ready to do that. I actually need to do some configuration. Ah, it crashed. It is nightly, yes. I might have to bump the nightly again. Oh boy. I didn't save before I opened that dialogue either, I don't think. Did it? I didn't even remember those. We're gonna find out, because we gotta do that. Now I have to go and find the location all over again. Yay. Okay, I'm going to update these. I'm then going to kill KiCAD real quick. Reopen it. Because then I don't have to keep updating this every time it crashes. I opened this the wrong way around. I can click edge cuts. That's a good start. Now, is everything how we left it? Yeah! Okay. I'm gonna actually do the edge cuts before we do everything else because I have no idea if I can even open the dialogue. I need to configure the pads. Yay. Looks like it's 9mm for where the cut needs to be in the board in width. Oh, they're advocating for 9.5mm. Let's see what we can do. We'll do this at the top. So that is on the edge cuts layer. That's a great start. That seems awfully wide. I guess that works though. So yes, you can now edit the edge cuts on the actual edge cuts layer. Awesome. Like, that actually works. Yeah. For this, at least. I don't actually know where this bottom line needs to be, so, I'm just trying to work out where that actually is. I'll show you what I'm dealing with here. This is the mechanical drawing. I want to scream. I really do. It's pretty bad. I mean, like, all the dimensions are there at least, but oh my goodness, the density. So dense. So this is that 9.5 we've just set up. They're then saying the top edge of the cut here needs to be 0.4 from this little lot. But I'm not sure how that relates back to the overall part length here. At least I think that's the overall part length. Oh. That's a useful dimension there. So that hole is 2.06 from the back edge of the part. Apparently. But like, what I wish they'd done is that they'd mentioned from this line to this line. That would be fantastic. Because I have no idea how far out this is supposed to protrude. Although I'm guessing... Which end of this is which? Yeah, I'll wrap up shortly. I'm just trying to work out, like, the front edge of this is... .15 from the side of this pin. But this pin is... I don't know. Like, this is saying 6.05 to A. A is... I think perhaps this? That would make some sense. Yeah, open ends on the bottom. So let's actually invert this to match. No, what they've done is they've gone and taken this front edge of the connector here, which is 10mm from the back edge, and they've said, well, this pin's front side relative to the front of the connector is 3.15 back. But then they haven't told me how wide that pin is in that diagram. I'm sure it is specified here somewhere. Yeah, here it is. It's 1.2. So it's 0.6 to the middle from the front edge. This is awful. I'm having to do way too much maths here. Let's see if we can get the numbers to agree. So we've got 3.15 plus 0.6 for the half the width of the pin, plus the 4 in the schematic diagram here to get to the back edge, minus the 0.4 to come forward. That brings us to back here. Okay. That number seems to work though. That gives me an idea for where this dotted line should be. So this needs to be 5 minus that. That appears to be what they're saying for the edge cuts. And actually that about lines up looking at the way that they've drawn this, that actually does about line up. So I'm okay with that. Now, if only I could open the dialogue that allows me to change how the pads look, so I could then start drawing pads in. Crash! Yay! Okay, I am going to bump the nightly real quick. You get to see how this works. Oh yes. If I was showing you the right console, of course. Nah, I can bump the nightly, it's easy enough. It's easily enough done. This is my KiCAD nightly console. Because I have a script. Does all kinds of really funky cool things. I'm just going to quickly make sure that the library nightly is happy. It is. I need to change the PKG build in, because this is why I've had to fix things the way I have. This should have been user share KiCAD nightly. Yeah, a little bit of a difference. Hang on. I'm missing something here. No, there's another path I need. Data DIR. That was the one. I need to unstage that commit. There we go. And now it does the thing. Oh yeah, there's a whole pile of new commits, so that might fix my bug. So there's the corrected footprints. And there's the corrected nightly. Which, will ignore VS Code, because I don't want to do that right now. We don't want to do a clean build. I don't need to see the diffs, I've just done that. And I don't want to edit any of those. And away it goes. How's that for crank the handle? I'm curious as whether or not this fixes the bug. If this does, I will be incredibly happy, and we'll then wrap the stream up. How's everyone doing on this fine evening anyway? Aww, you need pets. Oh, awesome. Glasgows are awesome. Oh, that reminds me of a thing I need to do. Sorry, I didn't get to doing that yesterday, like I was supposed to. Aki, you are completely excused on account of a lack of spoons. It's okay. Forgive yourself. I know that's really hard to do, but like, it's okay. Forgive yourself. Oh, Clang Tidy and includes is a whole thing. One of the things you can do with Clang Tidy is you can treat it like it's a compiler. So you can hand it Takai and other options like that, because it actually invokes the compiler under the hood. Oh, that's a whole thing. Yes, you can. That also works. I forget which option that is. I think it might be TAC P? Or is it TAC D? Really? I know I have it installed. Attack P for a build path, and it will then pick up the compile commands JSON automatically from there. Oh, yes. Yes. That makes for a whole lot of pain, as you are now finding out. If anybody's thinking that this is taking a while, this is my machine's utilization right now. Which, if we actually filtered this on KiCAD, yeah. It takes about 15 minutes on this machine. And it's doing it as fast as it can. And the encoder doesn't skip a beat.
It's great. We might have overbuilt my machine, love. I'm okay with this, for what it's worth. Yeah. Ha! Yeah. Single core was bad times. Builds are slow on single cores. I am so glad we came past those times and are now 16 and more core. I think the CPU is under spec now. Because we never upgraded it. But, yeah, okay. Room to grow and all that. It's just, price of 3950Xs are, yeah. I'm gagging for more cores still. Don't loot that. I mean, I need more cores. Because I'm running these kinds of workloads every day. Maybe. Where are we at? Oh, 3/4 of the way through the build. That's not so bad. If Beston was still watching, I think he'd be proud. Cause, yeah. One of the great things though about the whole nightlies that I'm doing, because I'm pinning the versioning, if we find that there's like a 3-day-old bug, we can go back 3 days in the nightlies, rebuild that one and reinstall it, and show that it's no longer a bug there. Granted, the 1/4 of an hour it takes to do this is quite a drag, but you can do it. I mean, I'd probably have to slightly bully my AUR helper, but I could do it. It's gonna want my password again, isn't it? Just realizing sudo will have timed out. Looks like the last two things it's currently building are basically PCB new and EE schema. Which, I'm not surprised that they're pretty much the largest part of KiCAD. So... You make a valid point. I'll fix that in the next nightly. That'll be tomorrow. We'll see if it works. I'll actually have to do a test build for that, because I don't know if they've got a clean CMake file or not. Half the time people don't. Oh yeah, core 16 there, getting unloaded a bit. Oh, okay. Then yeah, we can absolutely change out the dependency on make for a dependency on Ninja, and we can change the nightly over to Ninja and CMake TACG Ninja. That certainly works for me, because it's a lot quieter and faster. Oh. Rest in peace, Ultra Sid. If nobody saw the news this week, thank you Lethal Bit for making me aware. This amazing master of chiptune music unfortunately passed. It's been a shit week. So close to done. We're gonna see the first of the drop-offs here. It's doing a link step that it can't go past. And then it'll load it back up again. It's like, huh. It's almost exactly 15 minutes, yes. Still gotta do another quick spike to 100%, but... I think this is EE schema linking or something ridiculous. Do you think? Yeah, I was gonna say, I don't think it's been that long yet. There we go. Oh, it's PCB new that takes fucking ever to link. That's the step that we saw. Oh, we went up by 20 kilobytes. This bit always... The packages are... the 3D packages are just absolutely enormous. There's like 5 gig of them or something ridiculous. It's a crazy amount of disk space that this uses. But 3D view's worth it, I think. This is also a really brutal workload on ZFS, which is itself impressive. Oh no. Music cut out for a moment there. That was fun. Give me a second to find the right console again. There we go. That was a very high CPU load spike. That's why that happened. This is still putting them in the wrong spot. I'm gonna have to play with this some more after stream, probably tomorrow, to try and get these models to install in the right spot, because this is not the right spot. Nya nya nya. Cute. Okay, this is just gonna take a while, so I'm gonna boot KiCAD Nightly back up already. Because we've done the update part of it. So we should be good to go, maybe? Let's kill that. Oh, there it goes. I'm having to fix the fact that it got E schema and PCB new backwards. Huh. I'm just letting it compress that before I hit the go button. There it goes. Okay. Let's see if this fixed the crash. Who knows? Nope. Okay, that's where we wrap up. We wrap up to the fact that KiCAD just crashes in Nightly at the moment if you go and try and build a part. So this will have to be done in the non-Nightly and then imported. So yeah. I'm going to do a little bit of cleanup here. We don't want that, or that, or that, or that. There we go. That's better. Feels better. So, we managed to get this done tonight. I will get this ordered once I fix the small little issue I have just spotted right here. And next stream, next Saturday, I will be doing some more keyboard. I will be doing more Cherry MX keyboard. The aim of that stream is going to be let me bring up the to-do list. There we go. To do the fiducials, round racked pads, fix silkscreen, complete KiCADification of parts, as we keep calling it, and to finally get the key stabilizers in, because those items we didn't get done last stream. I also would like to look at the logic level converters, because I'm aware that they're probably the wrong ones. They're auto-sensing, so we need to fix that. So with that, I bid you all a fantastic rest of your day, evening, whatever time of day it is for you, and I will see you next Saturday. Ciao!